So we're going to look at our parent function right now, and then we're going to look at the characteristic of that parent function and what happens to the parent function as I change my values. So remember that the parent function is y equal x squared. So if x equals -4 and I plug in -4 squared, what do I get? So if I put -4 squared, what do I get? 16. Are we okay with that? Okay. How about if I put -3 squared, what do I get? 9. -2 squared, 4. -1 squared, then 0 squared, 1 squared, 2 squared, 3 squared, and 4 squared is 16. So you see that with the negative, I had to put it in bracket, right? Even on your calculator, you have to make sure that you have bracket -4 close bracket squared. It gives you 16 because it's -4 times -4. It gives you a positive 16. So the equation is y equals x squared, and I'm plugging in the x values to get the y values. First difference. So to do the first difference, what do I have to do? y2 minus y1. Right? So you're going to start at the bottom, and then you're going to subtract the top. So it's going to be 9 take away 16. Positive 7? So 9 take away 16. Then the next one, it will be what? 4 take away 9, which is -5. Then 1 take away 4, -3. 0 take away 1, -1. 1 take away 0, 1. 4 take away 1. 9 take away 4. 16 take away 9. Anyone have any problems with the first difference? Okay. Second difference. Now, first difference is constant? No. So I have to move to the second difference. And here's where a lot of you had, or some of you had problem yesterday. Okay? You have to be careful that you have -5 minus -7. Right? So -5 take away -7. What do I get? Positive 2. So remember, it's -5 take away -7. Right? So here's where I have the double negative, and that's going to become a positive 7. Right? So -5 plus 7 is 2. -3 take away -5. -3 take away -5. 2. -1 take away -3. 2. 1 take away -1. 2. 3 take away 1. 2. 5 take away 3. 2. 7 take away 5. 2. Did you expect the second difference to be constant? Yes, because it's a quadratic, right? plot, so let's graph your points. So when I'm graphing the x and the y, I'm graphing the x and the y as a point, right? So your first point is going to be negative 4, 16, negative 3, 9, negative 2, 4, okay? So I might not be able to fit all the points. So my first point is at negative 4, 16. I don't have 16 on my y-axis, so I'm going to skip that point. I'm going to go to the negative 3, 9. Okay? So negative 3, 9, that's negative 3, and that's 9, so that's where my first point is. Anyone doesn't know how to plot this point? So you're going to have to go on the x-axis first. You're going to locate your negative 3, and then you're going to have to go up to the 9, and this is where your point is going to be. Where both of the, so if you imagine this, you're going to draw a dotted line and a dotted line, okay, and where the two dotted line meet, that's where the point is.
They don't have to put a point where the negative 3, right?
No. Because it has to be at negative 3, 9, not negative, if you put it here, that's negative 3, 0. But I want it at the 9, so that's why it's right here. Negative 2, 4. So I'll go to the negative 2, then I have to go up to the 4. Negative 1, 1. Zero, 0. 1, 1. 2, 4, and then 3, 9. So if I'm going to graph this, it's going to be a smooth curve. And I put an arrow because that's going to keep going up. And I put an arrow because that's going to keep going up. Does this look like a parabola to you? Good. It should. If it doesn't, you've done something wrong. Okay? So let's look at the properties of this y equal x squared graph. Where is the vertex of this graph? Where is it located? 0. Vertex is a point. So it's going to be at 0, 0, no? Which also we call it the origin. The optimal value is y equals 0. It's the y value of your vertex, which is y equals 0. And it's minimum or max? Min, because the graph opens Where's your axis of symmetry? x equals 0. So the axis of symmetry is x equals 0. The graph is symmetrical about, okay, I want your eyes on me for a second. So what do we call this axis?
The y.
The y-axis, right? And in this case, it happened that the y-axis is my axis of symmetry, okay? So the graph is symmetrical about the y-axis in this case.
It's also the x, right?
It's not symmetrical along the x-axis, right? Because it's not, there's no symmetry here, right? It's only symmetrical. Remember, the symmetry line is a vertical line.
Oh,
How many times does my graph, or this graph specifically, intersect the x-axis? Once, right? And where does it intersect the x-axis? At 0, right? This is the case. That's why it's the special case. The 0 of the relation are x equals 0. So here is the special parent function. So the vertex is at 0, 0. The minimum is at y 0. Axis of symmetry is as x equals 0. Only have 1 0 at x equals 0. How about the y-intercept? How many y-intercept? Where is the y-intercept? Y equals 0. Okay, good. Now, there is a pattern when it comes to graphing quadratic functions. Okay, eyes on the board for me, on me, but all of you, eyes here. So when it comes to graphing quadratic functions in this format, here's the pattern. So from the vertex, if you know what your vertex is or where your vertex is, then to find your next point, you're going to go up 1 over 1. That's the first point. So you're going to go up 1 over 1 to both sides. You're going to find your first point after the vertex. Then to find your next point, you're going to go up 3 over 1. So up 3 over 1. Okay? Then to find your next point is going to be up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. Okay? So the pattern is from the vertex, first I'm going to go up 1 over 1 to both sides. Then I'm going to go up 3 over 1. Then I'm going to go up 5 over 1. And that would give me my quadratic. Okay? So we call this pattern 1, 3, 5 pattern. Now it will change depending on the vertical stretch or vertical compression, which we're going to talk about that next. Okay? But what you need to know is your pattern is 1, 3, 5 multiplied by the a value, which we're going to talk about that next. Okay? But the most important pattern, and you're gonna hear me say that, 1, 3, 5 pattern. Okay? It's because you go up 1 over 1, up 3 over 1, up 5 over 1. Okay? Now, I'm going to go to my desk and then we're going to explore what happens if I have something multiplied by the x squared. Okay? So remember that your parent function is y equal x squared. What if your function is y equal 2x squared? Or what if it's y equal 0.5 x squared? What changes? Or what if it's y equal negative 2x squared? Or what if, so what happens to my graph, to my original graph, if I multiply it by a number? Okay, that's what we're going to explore right now. Okay, so you don't need to do anything right now. You just have to look at the screen. So I'm going to use a graphing technology called Desmos. You can always download that app. It's called Desmos app or Desmos calculator on your phone, or you can use it on a computer. Okay? So here's what we're going to write. So for the first function, I'm going to write y equals x. And then what you can use here, there's a keyboard. You can use this for squared. Okay? Does this look like our original function that we have graphed? Right? It's at 0, 0. Then it's at 1, 1. If I look at this point right here, it doesn't want to, here we go, right? Same as negative 1, 1. It's at 2, 4, right? And so on. Okay. So the next graph that I'm going to graph, eyes on the board, please, is y equals 2x squared. So y equals 2x squared. So what did you notice about the graph? So here's your original graph, which is the red one. And here's the blue one. Can you guys compare the two for me?
More narrow.
It's, which one is more narrow? The blue one. How about the vertex? Same. How about the axis of symmetry? Same. How about the optimal value? Same, right? So the only thing that changed is that it became narrower. Yes?
Yes.
Good. Now let's look at y equal 0.5 x squared. Compare the green one to the red one. We always compare to the red one. So compare the green one to the red one. What can you tell me? It's wider. Still opens up? Still 0, 0? Good. Now, if I give you another one and then it's going to be y equal 3x squared, what do you expect it to be? It's narrower than the 2x squared even? Okay, so let's look at that. Y equals 3x squared. You see it? It's right here. So it's narrower than even the blue one, right? So what is this value A doing to your graph if it's bigger than 1? What is it doing to your graph?
Thinning it out.
It's making it narrower. Okay? Does anyone have an elastic band? Here, I have one. So, eyes on me for a second. So here's your original graph, okay? And I want to make it narrower. What do I do to it? Which way? Vertically, right? If I vertically stretch it, I make it narrower, no? Okay, so this is my original one. To make it narrower, I have to vertically stretch it. This is exactly what I'm doing to my red graph. I'm making it narrower. So basically what we're doing when we're multiplying by a 2 or by a 3, we are stretching it vertically. Okay? So the way that we're going to describe it, we're going to describe it as a vertical stretch. We're not going to say narrower, but in our head we know that it's going to become narrower. Because what I'm doing to it is I'm stretching it vertically to make it narrow. Okay? Now, same graph. If you want that elastic band, if you want to make it wider, what do? stretch it horizontally. But because I can't touch the horizontal stretch, what I can do is, if I want to make something flat, I compress it. I press on it, right? So instead of stretching it, we're going to compress it, and it makes it wider, okay? So the two things that we're doing a vertical stretch or a vertical compression, okay? So what this is doing to your graph, the 0.5, is vertically compressing your original graph. Does that make sense to you? Okay? So just by multiplying your x squared by a number, it's going to change the shape, not the shape, it's going to change the stretchness of your graph, okay? The look of your graph. It's going to make it narrower or it's going to make it wider, okay? Now, they all open up, correct? Good. What do you think I have to do to the x squared for it to open down? So multiply it by a negative number. Let's see. So you think if I have y equal negative 2x squared? Aha. So that a value, if it's negative, it's going to cause the graph to flip. We call this, if you're standing here and you see yourself in a pond, what do you call that? Reflection. And this is what's happening to my blue graph in this case. It's reflected. We call it a reflection in the x-axis, right? Because it's reflecting through the x-axis, okay? So if A is negative, we have a reflection. If A is positive, we don't have a reflection. But we still have a vertical stretch. So what's happening here, the negative is causing it to flip, and the 2 is causing it to stretch. Okay? So here's your original. Eyes on me. Here's your original. The negative is causing it to flip, and the 2 is causing it to vertically stretch. Okay? How about if it's negative 0.5 x squared? Same thing, but wider. 1.5 x squared. And you see here, it's flip through the x-axis. So it's going to be flipped because it's negative, and it's going to be a vertical compression because it's wider. Okay?
So vertical compression is less than 1?
Yes.
And vertical stretch is greater than 1?
Correct. Okay, we're going to talk about this. All right. Now, all of you, tell me, the vertex for all of these graphs, did it change? No. All right, so let me do this. Let me just take a... All right, so let's describe this. So what's the value of A here? 2. Which way does it open? Which way did the graph open? Up. What was your vertex? The axis of symmetry? X equals 0. And then what happened to the graph? It was narrower, right? What did we say to make it narrower? What do we have to do? Vertical stretch. So for y equals 0.5 x squared, what's the value of A? 0.5. Which way was the graph opening? Up. What was your vertex? Axis of symmetry. And then what happened to the graph? It was narrower, so what do we call that? Vertical compression. And then for D, what's the value of A? -2. Which way did the graph open? Down. Bless you. And the value of your vertex? Axis of symmetry? X equals 0. Vertical stretch, but we also have to add to it. So for vertical stretch, I'm just going to write VS. Okay? VS, and you have a reflection. Don't forget the reflection. And the last one, -0.5. Which way did it open? Vertex. Axis of symmetry. Again, I have a vertical compression, and then there is a reflection. So, there's two things that A does to your graph. It either vertically stretch or vertically compress, or it can also reflect through the x-axis. Okay? So, the sign of A indicates the direction of opening. The sign means, is it positive or is it negative? So the sign of A indicates the direction of opening. When A is positive, the parabola opens up. And if it opens up, it has a min. When A is negative, the parabola opens and has a max. This is known as a reflection in the x-axis. And here's how you're going to remember this. Negative. Eyes on me. So negative A. Which way does the N open? Which way does the N open? Opens down. Right? So a negative A is going to cause the graph to open down, like the negative. And positive, you know, when you're positive, you're feeling happy, right? A smiley face, right? But remember that negative a n opens down, so the graph is going to open down.
Also not like the frowny face.
The frowny face. Yep. What's going on? When you have open up, it's a min, right? When you're opening down, it's a max, right? It's a hill and a valley. Okay. Then we said that the value of a describes the shape of the parabola, right? So is the parabola going to be wide or is it going to be narrow? So the value of a describes the shape of the parabola. When a is between 0 and 1, give me examples of a number between 0 and 1. 0.5, 0.25, a quarter, right? 1 over 4, 1 over 6, right? Anything that 2 over 3. These are all numbers between 0 and 1. The parabola is wider than y equals x squared. Remember, we're always comparing to y equals x squared, and known as a vertical compression. When a is greater than 1, give me example greater than 1. 2, 4, 2.5, 7, right? Negative 7, still. The parabola is narrower than y equals x squared and known as vertical stretch. So, by looking at the equation, if I give you y equal negative 7x squared, for example, you should be able to tell me that the parabola has a reflection in the x-axis and it's vertically stretched. Right? Okay. Last thing we're going to do today is this. So they want you, the question is actually at the bottom of this page. So for each of the following, state the transformation. Guys, I can't explain to you how many students don't know when they read the question, they don't know what the question is asking them on a test. When I'm asking you to state the transformation, I want you to tell me if there is a reflection, if there is a vertical stretch or vertical compression. This is what transformation means. Okay? Later on, we're going to learn other kind of transformation. But for today, remember this word because you're going to see it too often. State the transformation and then graph. Okay? So let's look. So y equal negative 2x squared. So to state the transformation, what are you going to tell me? There is a reflection because it's negative, right? So we're going to say reflection where? In the what axis? In the x-axis. This is what I would like you to write. And then what else does it have? 2. What does it do to your graph? Vertical stretch. I stated my transformation. Okay? Because of the negative, I have a reflection in the x-axis, and the 2 is causing a vertical stretch. What's my vertex for y equal negative 2x squared? What's, sorry, the vertex, yeah. 0, 0, right? This is where all the vertexes were, right? It's not going to change. The vertex is going to be 0, 0. Now, here's how you're going to graph this. Eyes on me. You haven't done this yet. Okay? So, what's going to happen is you're going to always state your vertex first. So, the vertex in this case is 0, 0. What is the regular step pattern? 1, 3, 5. But because I have the vertical stretch, it's going to change the step pattern. Remember, I told you that the step pattern is A times 1, 3, 5. Do you remember that? Yes. Okay, and I told you we're going to see why it's A. Because A is the same as this A. Right? Remember that this is the transformation of y equals ax squared. Right? So that a is negative 2. And that is going to multiply my 1, 3, 5. Okay? So what are my step pattern? My step pattern is negative 2 times 1, 3, 5. So what's negative 2 times 1, 3, 5? Negative 2 times 1 is negative 2. Negative 2 times 3 is negative 2 times 5 is negative 10. So my 1, 3, 5 means go up 1 over 1, go up 3 over 1, go up 5 over 1. Right? But now it's negative 2. So what does that mean? Down how much? 2 over 1. Always. Then go down 6 over 1. Then go down 10 over 1. Okay? So this means down 2 over 1, down 6 over 1. I might not be able to do that because it probably will not fit on my graph. But that's fine, okay? Because by then I have 5 points. So here's my graph. I feel like Picasso right now. Okay. Why did I graph my x on the top and then I have lots of negative? Because I'm going down. Remember that? So I plan ahead. Where's my vertex? 0, 0. Then it tells me I have to go so from the 0, 0, I have to go down 2. So that's 1, 2 over 1. So I'm going to end up here. Yes? Do you guys understand that? So I went down 1, 2 over 1. Can I go over 1 to the left? Okay. Then, down how much? 6. So I'm going to go from this point, I'm going to go down 6. So that's 1, 2, 3, 4, 5, 6 over 1. So I'm going to end up at this point. It's going to be exactly the same on the other side because of the symmetry. Remember my symmetry? And this is my graph. I'm going to give you the scale for the next one. I want you to graph it. I want you to do this question with the person sitting next to you, and I want you to graph it for me. And I'm going to give you the scale.